And now it's time to have Don Song, a professor at UC Berkeley of Computer Science and Electrical Engineering. Don Song.
Great. Hi, everyone. Thanks for being here. I'm Don Song, professor at UC Berkeley. Today, I'll talk about confidentiality preserving smart contracts and democratizing AI. Yeah, we are here really excited about blockchain, and we hope that blockchain can help revolutionize many segments of the industry in the future. But however, today, so far, what do we have? We have store of value, decentralized payments, ICOs, and so on. So the question is, can blockchain help solve even bigger problems? So what are some of the bigger problems that blockchain can help us solve? Besides blockchain in the nano domain, in AI and deep learning, also we have seen great advancements. For example, AlphaGo has won over world champion, and deep learning is empowering everyday products. And many nation-state leaders have recognized that whoever controls and leads in AI will rule the world. So the question is, who are controlling AI and who will be controlling AI in the future? So where are we today? So today, we have big companies that collect users' data and then use this data to train personal profiles. And already, they are providing various services based on users' data to users. For example, providing driving directions, giving you job advice, and even giving you a life plan. But however, these assistants to users, essentially, they're controlled by these big companies with the goal of maximizing revenues. So the question is there a different future? For example, is there a different future where we can have intelligent agents that are under user control, and these intelligent agents can still leverage third-party services, but these intelligent agents will be providing users with driving directions, job advice, and life plans, and with the important difference, which is that they are under user control, and hence their goal is to maximize user value. So this is a really challenging question. The question is, can we get there, and how can we get there? Towards this goal, at Berkeley, we are developing a research project called AI Eden for blockchain for democratizing AI. So how does this work? So first, let's look at one example scenario, the scenario of credit score services. So Equifax is one of the top credit score companies. So how it works is essentially Equifax collects information from users and then trains a credit score model. So when a new user wants to get its credit score, for example, for getting a loan, the user can then query the Equifax to try to get a credit score. However, in this setting, in the centralized setting, there are a few issues. One is that the company actually owns and controls the credit data. Users don't have direct access to it. And the Equifax, in this case, is responsible for securing the credit data, and also Equifax can decide what credit rating actually to give. And also only Equifax talent is used to build the credit scoring algorithm. And many of you may have heard about the recent Equifax data breach, where attackers was able to steal sensitive information about over 140 million people. So the question is, can we have an alternative that utilizing the power and capabilities of distributed systems like a blockchain to have a different solution? So here in this example, with a new type of capability for smart contracts, in particular, a confidentiality preserving and privacy preserving smart contracts, we can develop a credit score service on top of blockchain that solves many of the problems that I mentioned. So in this example, here we have a smart contract that actually contains different parts of the code. One part actually is a machine learning training algorithm. Also, it trains what we call differentially private machine learning for essentially for developing a credit score model. And also when the model is trained, the smart contract also contains a code to serve the model. And in addition, as a smart contract can enforce terms of use, so the smart contract can also specify, for example, how users' data will be used, and also if, for example, the smart contract in the end actually makes a profit, how the profit will be distributed. For example, if users contribute their data, then these users can then get to share a part of the profits. So in this case, users can maintain control of their private data, for example, their financial information. And if they agree with the terms of use of the smart contract, for example, the smart contract can say that users' data will only be used for training differentially private credit score model, and also the user will get benefits from, in the end, the model service. Then users can decide that they want to contribute their data to the smart contract. And as the smart contract gets enough contribution of users' data, then it can then actually train a high-quality machine learning model for the credit scoring. And then when new users need their credit score rating, they can then query the smart contract to get their credit score, and then use the credit score, for example, for getting a loan and so on. And also, as I mentioned, one important aspect here is that the smart contracts also is confidentiality preserving that I'll talk about in a second, so that the data and the execution, the computation in the smart contract is protected, and hence, in this case, users can protect their privacy, and at the same time, the smart contract actually gets to now have this capability of training credit score models and serving this credit score models. And using this capability, the confidentiality preserving smart contracts, we can then, as the example that I just showed, can really enable a lot of new applications and new capabilities to be built on top. And the way we achieve this confidentiality preserving smart contracts is to leverage various secure computation technologies, for example, by combining trusted hardware as well as crypto-based solutions such as secure multi-party computation. And using such an approach, the user's data and amount of access can be dictated by smart contracts, and the smart contract essentially can expose highly available microservices to the users and even other smart contracts. And this approach can ensure high level of security and privacy with theoretical guarantees of the design. So in our research projects, we have developed this new confidentiality preserving smart contracts, and we achieve a number of goals, including ensuring the correct execution of contracts, protecting secret contract state, providing fault tolerance and high availability, strong consistency model, and also scalability and high performance. So with this type of technology, we can then enable a new type of blockchain that enables intelligent smart contracts, where we can then, again, on one hand, we can enable users to still maintain control of their private data, but on the other hand, we can actually leverage all these different data sources and together build machine learning models, and then use these machine models to enable new capabilities that couldn't be enabled before. So I've talked about the credit score as an example, and there are many other examples that such a technology can enable, including building differentially private financial service models, fraud detection models, or in the healthcare, building medical diagnosis and treatment models. So as I mentioned, one of the key capabilities that enables this confidentiality preserving smart contracts is by leveraging secure computation technologies. The goal of secure computation is to protect the computation process from leaking information about sensitive data. And then there are a couple different types of approaches that one can use to enable secure computation. So one is crypto-based secure computation, including, for example, fully homomorphic encryption or secure multi-party computation. So one challenge for this type of approach is that the performance overheads can be very high. Often, it results in orders of magnitude performance overheads over native computation. Another type of approach is hardware-based secure computation. For example, leveraging secure hardware to provide an abstraction for trusted execution environments, such as a secure enclave, where Intel SGX is an example implementation of a secure enclave. So what secure enclave enables is it's a hardware-based isolation mechanism that can, when a program is running inside a secure enclave, the outside operating system or the other application processes will then now be able to access what's running inside the secure enclave and also cannot modify it. In this way, the secure enclave can provide the integrity and confidentiality for the program running inside. And also, the secure enclave provides a hardware-based remote attestation capability that enables remote verifier to verify what program has run inside the secure enclave and what the initial state is. So, in fact, the secure enclave can serve as a cornerstone security primitive. As I already mentioned, it provides very strong security capabilities. It can help authenticate itself, the program, even the device, and also can guarantee the integrity and confidentiality of the execution. And secure enclave can serve as a platform for building new security applications on top that couldn't be built otherwise for the same practical performance. And all the hardware manufacturers have recognized the importance of building secure hardware. So over the years, they all have developed different types of solutions for secure hardware. However, there are still many open challenges in secure hardware. For example, how secure can it be, and what's their models? And what would you entrust with secure hardware? Your Bitcoin keys, financial data, or health data? And the ultimate question is, can we really create trustworthy secure enclave as a cornerstone security primitive that can be widely deployed and enable new secure systems to be built on top? If we can do this, then this will really enable the whole community and society to usher into a new secure computation era. So what's the path towards building a truly trustworthy secure enclave? There are several important steps. So first, we need to have an open source design for secure enclave. The open source design will help us to provide the transparency and that can help enable high assurance. With the open source secure enclave design, the whole community can work together to analyze and verify the security and correctness of the secure enclave. And also, open source design helps build a community. And also, ideally, we would like the secure enclave to be formally verified, and also to ensure secure supply chain management to ensure the security in the manufacturing process. Towards this goal, we have a new project called the Keystone Enclave, and with the goal of building an open source secure enclave design. As a first step, the Keystone Enclave will be built on top of an open source RISC architecture called RISC-V that has been developed at UC Berkeley. RISC-V has been widely adopted in industry with the RISC-V Foundation has over 100 plus members. And with the Keystone Enclave, we plan to have a first release this fall with more full-featured release next year. So altogether, when we put these technologies together, we hope to enable this confidentiality, preserving, and scalable smart contracts. And on top of this new blockchain with these new capabilities, we hope to build a blockchain of intelligent smart contracts that can really help democratize AI. And using these capabilities, we hope to really help enable intelligent virtual assistants that are actually under user control and to help maximize user value. There's a lot to do here, and it's a community effort. So let's democratize AI together. And stay tuned for further announcement. Thank you.